to share some thoughts about how we warn in the Netherlands, how we do it now, and how we are going to how we want to do this in the future. This presentation is made by myself, but also with the help of my colleagues, Kenny, Jeanette, Marcel, and Rob. As you can see there. So yeah, about the presentation, it's a very simple presentation. I want to tell something about how our warning system is working now, and then with a focus on impact-oriented forecasting. And then I want to tell something about our future plans and how this will be part of our early warning center, where we want to grow from more traditional weather room, operational office, into an early warning center, where we want to merge the different geophysical hazards into one warning center. So not only weather forecasting, but also other geophysical hazards. For the Netherlands, for example, the water and dikes are very important. Yeah, so we want to integrate more and more all these geophysical hazards. Yeah, something about myself. My name is Jos Diepenveen. I work as a forecaster since the beginning of this age in the build in the Netherlands. Here is a picture of myself in Saint Martin in the Caribbean. And because we have there also some islands which are still part of the Netherlands, and yeah, I want to tell also something about that later on. So I was working the first years with satellite interpretation of satellite imagery, besides my work as a forecaster, in the Submanu project, later in the Humatrain project. It's a very nice collaboration with different European countries. And I saw Frans de Bie is also present, and together with him, I did a lot of work there in designing conceptual models for weather forecasters. So there's always my interest, this satellite thing. Later on, I became also the crisis manager in KNMI. About a year of 7, 8 ago, and also designing the warning system which we now have. And later on, I was involved by developing also a warning system for the Caribbean. And now these days I'm team manager of the weather room. Yeah, that's not the biggest part of my job now. And working still with development of warning systems. And for the rest of my period, I work also still in the bedroom as a forecaster. But it's a few shifts in a month. Further on, I am also active as the vice chair, one of the chairs of the working group collaboration between European forecasters. I do this together with Christian Tekic. We have a very nice working group with different forecasters from all European countries. We organize meetings every year. Now with COVID, it's a little bit more difficult. And there we also exchange a lot of information and thoughts, working methods about forecasting, also more development of forecasting tools, forecasting systems, but also about impact-based warnings and things like that. So all what has to do with forecasting is being discussed there, and also the relation to more the research. So that's about myself. And yeah, I think still it's a very interesting field of work. Forecasting and studying the weather, and also making the relation to the user. So that's more and more my interest. And now something about our actual system for the Netherlands. The Netherlands is a small country with a lot of people. I think it's the most dense populated country in Europe. We have about 17 million people in this small country. So when the weather does something, most of the time it has a lot of impact, especially on the infrastructure of the Netherlands. So therefore we have already, I think, for about 8 years, a system which is also based on impact. And the nice thing of this actual more hybrid warning system is that we for a yellow code, there's not much impact taken into account, but when you going to orange and also later on to red, more impact will more and more be weighed in making the decision of issuing a weather warning. Now for the system now, at the moment we warn only 48 hours in advance, so it's 2 days. That's for yellow. And for an orange code, we warn only 24 hours in advance. And phenomenon must have a size of 50 by 50 kilometers. And the code red is mostly impact based, and we only issue this for 12 hours in advance. At the moment, we still warn at the province level. Now, it's already a small country, so the provinces are even more smaller. So that works quite well. But of course, there are still some larger provinces which can be quite difficult in differentiating your weather event to a proper warning. So we want to change it, and I will tell what the ideas are in this. So for yellow codes, it's very simple. The forecaster can issue a yellow warning, and he can do this directly without having some discussion, and just complete his own job. And he can make this on province level, and on the province they get a timetable when the warning starts and when the warning ends. So it's typical yellow warning where we have the message to the public, just be alert, so which is a quite common system in Europe. For an orange warning, it's working a little bit more complex. Here is an example. We make some kind of impact light, as we call it here. We have the forecaster, which sees some more severe weather coming in our amber thresholds, and then when the orange warning exceeds a probability of 60%, then an internal KNMI team comes together. It's now these days it's all done by a video call, like we do it now. And there's a short discussion internally, KNMI, with a forecaster, model expert, a climatologist, some person which has the contacts with the civil protection authorities, and a communication expert. And then we are discussing the situation and having an idea whether we issue the orange or we keep it yellow. And besides this discussion, we have also a consultation with the private companies, so they can also give their view on this typical on this weather situation and have their input in this decision. And in the end, the chair of the expert team decides about issuing this amber warning, and then the forecaster will issue this at the bench in the forecast office and issue this warning. And of course, don't be afraid that the forecaster has nothing to say. He has a very large influence in the decision which is made in the end. And we call this more like an impact layer. So then we making it already a little bit broader than only the meteorology. So we take some private companies into account, some experts within the institute, and in the end, we will issue this orange warning. Then for a code red, it's of course then in the case of a red code, you already have most of the time already an amber or an orange warning issued. So this whole thing about the expert team and the private companies, you already run this job, you did this already, the information is there already. And then in a potential red situation, we have a weather impact team. And in this weather impact team, we have basically the main people represented from the most infrastructural agencies in the Netherlands. So that has, we have a lot of water, the party from the highways and the road infrastructure, railways, also aviation takes into account, and also the safety of people is being represented by different crisis organizations, which have their idea what's going on in the country with all the civil protection authorities. So this team then makes them together with the chair of the expert team. This team of impact partners has a short meeting, which is being done also by video, and then advice has been made by the crisis center to KNMI whether to issue a code red or not. And as you can understand, that's being done by the actual impact and the impact which is being expected by the typical case. And for now, we do this now already for a year of 9, 10. We see that still for all these crisis partners, these civil protection authorities, it's very difficult to imagine what impact will be if you just tell him what the weather is going to be. So this relation between weather to impact is still very difficult. We have some very nice cases, and so we want to improve this system, but it starts of course with the existing collaboration which we already have. So we have all these contacts are already being made, but now we are in the stage of more optimizing this relation and getting better and better this impact information into our working procedures. And I'm going to tell later on how we are going to do this in the next years. So this is about warning in the Netherlands, and what is very important is that for impact-oriented forecasting, you have your network, your crisis network, okay, that you have the context within the important crisis organization within your ministry, and if you have this fixed, then you can work. And it takes time to more and more impact-oriented forecast system. So that's the lesson you can learn if you want to do more with impact-oriented forecasting. Then that's the starting point. Make these relationships and also make agreements that you are available when there is a crisis coming to each other. So that's already the first step, which we last year we made some steps in, and still I have to be honest. Then it's still sometimes a struggle to make the right decision whether issue a code red or not. But at least the contexts are being made. So it's a process which really takes time. So that's about the Dutch forecast system. I'm now going shortly to the Caribbean region, and then after I presented that, I want to take you into the changes we are going to make in the European warning system which we are going to do next year. But yeah, for now in the Caribbean we have also some funny islands which are part of the Netherlands. There are 3 islands here in the south, north of Venezuela, Aruba, Curaçao, and Bonaire, and we have Saint Martin, Saba, and Saint Eustatius, where to make it more difficult, 3 islands are really treated as municipalities, and the 3 other islands are like independent countries within the Netherlands. So forget this all, but actually it comes to the point that we make forecasts for 3 islands, and the other 3 islands, they have their own meteo service. So these are the 3 islands. It's Saba, this one, Saint Eustatius, this one, volcanic islands, and we have a more coral island in the south, that's Bonaire. We do make the forecasts and warnings for these islands from beginning, starting from 2016. Before that, it was being done by Curaçao, but there were some problems and some so we decided to take over this warning and forecast for these islands. So as you all know, it's another sport than forecasting in the mid-latitudes. So we have to deal, of course, with tropical weather systems, which most of the time start as a tropical wave at the west coast of Africa. Most of the time, it's convection going with the easterly passat flow, and then developing into a tropical wave, and it's a tropical depression, and then it becomes tropical storm, and sometimes a hurricane. And then we are responsible to warn these islands properly. Now, for example, we had this Irma in 2017, which had a devastating influence on Saint Martin. So that was also for us again a trigger to have a closer look at our warning system. And after Irma, there was a Maria also coming. So that was a whole train of 3 systems which were moving close to the islands. And actually, for this system, we have just a yellow warning, which is information from 72 hours. And then for in the closer terms, we work with tropical storm watches and tropical storm warnings, and hurricane watches and hurricane warnings. And then we follow the National Hurricane Center, and we are then in a close cooperation with the National Hurricane Center. So this is basically the warning systems we do for the Caribbean, and then most of the time it comes down to a very simple warning, where we have some key messages, what the most likely is to expect it, and what we also do is we make some kind of worst case scenario. You see that here, where we stress the most worst case, what could happen, and so that they have the most likely scenario and the worst case, and this then being worked out in this text bulletin with an image of the track of the hurricane. This was a short sidestep about, but I thought maybe nice to show you that as well, that we are making warnings also for the Caribbean region. And I can tell you the whole day about it, but so it's very short. And now I go back to the Netherlands, of the European part, the ambition and the vision which was being formulated is to make our warning system more flexible, and you can see it here in these keywords for every place, and if we are based on reliable information, and also with a nice time scale, and we want to add also user perspective on impact. And one thing, this is a very nice sentence, but it's a little bit high over. In the end, it comes down to my opinion, and I start more and more to realize it the longer I am in this field, that communication is very crucial for a good warning system. So you can do meteorologically all the best you can, and you have yourself the idea that you made the best forecast. But if this message doesn't reach your customer, doesn't reach the public, then actually it's useless. So, and that's I think that's the second thing we have to consider, that for making more impact-oriented forecasts, we have to have good relations with our professional customers, the civil protection agencies, and for the public, it's very crucial that you know how your message is being translated by the end user. So you can make the most interesting scientifically right things, but if somebody doesn't understand your message, it's completely nonsense. So, and that's actually something we want to develop more and more from the eyes of the user, coming to a warning system which is suitable for them. And the main development is, of course, regionalization, personalization, so that somebody can see something which is relevant for him. That impact is more and more standardized. I'm going to tell you about that. And that we have this differentiation between general public and professional end users. It takes a little bit too much to tell you everything in detail, but I want to take out two highlights of this development. It's that we want to warn more personalized and more with more detail and more regionalization, especially more detail, and impact-oriented forecasting with use of user perspective. But I start with the more regional forecast, and this is actually the idea we have. This is the system how it works now. In the left side, you can see our warnings on the province level and how it's being communicated to the regions, and where they can see the time with a time bar where the warning is relevant for a people, for a person, or organization in this province. So that's our system. We want to grow in time to a more polygon-based system, where we can draw a polygon and assign your warning to a region, and this assignment of this region can be done by choice of the user. So if you want it on a province or a municipality level, then it's being okay. If you want it on a province level, you can take out that one. So that's a flexible output system. So you see this here, for example, for municipalities, and eventually it will come within an app that you can, that a specific user can see this specific warning, and also have an idea of the warning, how it's being presented for the whole country. And I have some illustration about that. For example, we had in 2016, we had enormous hail storms in the southeastern part of the Netherlands. And you can see it here. About, you can see baseball, baseball size hail that was coming down. And uh, a rather impressive storm, especially for Dutch, yeah, what we are used to. It was pretty impressive, and I want to show you now how we won this. There was an enormous impact because in that region there were a lot of greenhouses which were completely destroyed, as you can see here. The damage was about 250 million euros. One of the most expensive damages of the last period. And you see here that the hill size and also the impact on houses, on cars, and also on crops. It was enormously. But have a look at how we want for this particular case. Here is the radar imagery, the pseudo copy. It was actually this storm which caused this disaster. And look, our warning was like this. So you make a complete large area orange, and this was the actual warning before the lead time. And then in the end, the impact really takes place in a very small part of southeastern Netherlands. And of course, in a pre-warning for convection, you might have this region for say a day in advance. But when it's happening, and you really want to warn, of course, more specifically, and also make a distinguish between what's really the pre-warning and what's really happening. And that's what we are aiming to do with more regionalization of our warnings. The idea is that we go like in a seamlessly way from an early warning to a short warning. So we want to change this part of a forecasting system from, say, I told you in the beginning that we warn 48 hours in advance. So we want to warn 7 days in advance, if it's possible, like with this polygon, with a first indication of there might happen something within a week in this part. And then when you get closer to this event, then we are going to specify it more and more with use of polygons and probabilities. And when it's really happening, then we are changing towards, and the DVD already uses this system. We use an algorithm for the convection, and then you see the actual warnings which are based on nowcasting. So that's really the short time, the nowcasting. Here is the warning, and here's the early warning. And we want to do this with a tracking tool for convection, which is now being developed. We have now the first results of this tracking tool. You see it here, and it's almost operational now, and we will experiment coming summer with this tool, and where we have also already polygons. They are based on hill size and on reflectivity of the radar, and we are at the moment working to broaden this algorithm towards also other parameters, and the development department is busy with it. So next summer we will have an experimental phase with this new polygon tool. So that's what we how more spatial detail will look like in the future. And the next thing I wanted to talk about is about impact-based forecasting. And I think that's a difficult one for me myself. I am already 20 years working as a forecaster, and we are very tend to tell what the weather will be because we are scientists and we like numbers, and we like the technical aspects of weather, and that's for us. We know very well what that means in terms of how the weather will look like. But of course, for a user, a wind gust of 100 kilometers in an hour is just a number, and he has no idea what he can expect with it. So this phrase is, of course, and we know it all from the Met Office, that it's for a user, it's more important, not what it exactly will be, but what it will mean for yourself and also for the people which are in your surrounding, which are more vulnerable. And of course, we have here this impact matrix, which is very known, and you see also here this diagram of impact-based forecasting. But for the Netherlands, we overthought all these theory again. Already what our experiences are with impact-based forecasting for the last years, which I showed you. And now we came up actually with a slightly changed vision on impact-based forecasting, which is more impact-oriented. Because the danger of making an impact-based forecast is that the variables of impact and meteorology are becoming a little bit fuzzy, and they are walking to each other, and you cannot distinguish anymore what is what. And therefore, we are working now on a new idea of making impact-oriented forecasting. Because in the end, I think it's still the case that you have to warn people for what could happen, and not what literally will happen with the weather, but what could happen with themselves. And it's actually quite a simple idea which we worked out, and it's an extension of what we already do, and which I present you in the start of this presentation. So now the idea is, and I told you already that what first is very important is that your relation with the crisis organization is very good, and that you have short contacts with all the important stakeholders which are responsible for the safety of the country and the society. And what we are now are working on, and we are being helped also by an external organization, is the following idea. In the cold phase, I mean that's the phase where things are normal, when you have a code green, and when you have no crisis or no severe weather coming very soon. You can work together with your impact partners on a 24/7 potential impact database, which you have located somewhere in the cloud, which is quite obvious these days, of course, well protected. And this potential impact database, there you can score all the elements which are relevant for the different stakeholders, for your railroads, for the aviation, for the safety of people and vulnerable people. And so that's being done all the time, and that there you can describe your potential impact. And so when time evolves, there comes a moment that, of course, severe weather is coming, and then things getting a little bit more warm, too hot, and then it becomes interesting you get into a warn phase where you have, again, this already known potential impact. Think of time of the day, time of the year, time of the week. Now, are there already known events? So you have this potential impact, but then you get, because you know already a little bit about when to expect this severe weather, you can add more specific impact into this impact tool. And together with the potential impact, it makes your actual impact. And based on this scoring, you can weigh your warning. And the way we are now thinking about is to keep it meteorological. That's the 0. Then you have just your meteorological thresholds. So it will be an orange warning. So then you have, and when the impact is not lighter or heavier, then you just have your meteorology. But when there's a lot of impact to be expected, you can plus your warning, for example, from a yellow to an orange, or from an orange to a red. Or on the opposite way, you can make it lighter. If it's, for example, in the middle of the night and it's in a very less populated area, and there's not much impact to be expected, you can tune down this warning. And that's actually very simple the way we want to do this. But it's, of course, what's very important is your impact database, which you need to have okay. And now I have a little bit the previous slide in a little bit more detail. So you have your meteorological criteria together with your potential impact in the cold phase gives a first guess code. Then you can discuss this in the weather impact team, and that gives the actual idea of the impact. And such a database has to be developed, of course. And what we also have arranged is that the development of this database is under the responsibility of our crisis center. So we are not going to do this. It's not our piece of cake. It's being done by the crisis center, and they are going to construct this database. So that's for the cold phase. So there you have to have a good idea of your different partners, a good relation. You have to have a good idea of what their vulnerabilities are, where their risks are, and together you can then score the different relevant issues for their field. If you go to the warn phase, so when things are really going to happen, then you have this already known impact. You combine it with this impact tool with the actual impact, which is relevant for the specific event and specific time. And together with that, you discuss this in this weather impact team, which I already mentioned and which we keep going on with. And then in the end, together with this impact tool, this plus 0 of minus will come out, goes back to the KNMI forecaster, and he can issue the code which is being desired. And the nice thing of this way of working is that if you, it really distinguishes between the impact, which is being done by your impact partners, and with the meteorology. And when you issue, say, a lot of warnings, and all the time it comes down to a 0, then you can say, well, it's nice to have these impact partners, but what's the added value of it? And then you can evaluate this, and you can tweak the system more and more, so that you can get more information out of this impact partners. Because I told you before, that's the thing we are struggling with now, that you can tell them very well, this is the weather, this is what we are expecting, but they can, imagine quite difficult. They have difficulties to describe the impact. And so we are in a loop working on a more and fine-tuning this impact system. And we deliberately do not use the impact matrix for this because, in our opinion, it's too difficult for the collaborating organizations to work with this. But again, as I told you, it stands with the creation of this impact tool, and so together the whole schedule will look a little bit like this, and it's a lot of information now all together. But basically, it comes down to the first slide, which I showed you, that you have to, in the cold phase, you have a good idea of your potential impact, and in the warm phase, you get your more specific impact, and that's all being fed into this tool. The outcome of this tool is being discussed in the weather impact team, where KNMI is also part of, and then the advice comes what you do with your meteorological warning. And in some cases, it can just be your meteorological warning, because and that's something I didn't include in this presentation because it takes too much time. You can also imagine a situation where you have so much meteorology to say. For example, when we have deep depression over the North Sea with a 12/4 wind with gusts till 70 knots to 140 or 150 kilometers an hour, then this whole impact is nice, but you know already that it's being code red. So you can just then shortcut this whole impact story, because you know already that the meteorology is going to give a red anyway. So that's a very simple example, but this system can also give us the freedom to directly issue a code red without having too much impact, because then you know already when that the weather is going to impact anyway. But I worked it out in other slides, but I haven't included this, but it's just an example. And so for every time step, we have different scenarios which can be the case. So it's quite complex if you work this completely out with different parties. You have the forecaster, you have this expert team which I told you about, you have this impact partners, and they all must work together in a way, in an efficient way, that you are already also you have some lead time for your warning. But if you have it worked out nice and correct, then then it can work. And what of course is very important is that you train this system also quite frequently, and not only wait till something really is going to happen. Now this is and just this is in Dutch. Excuse me for that, but this is an example of this impact tool, and it can be very simple. You just can score the different elements in a score. That's the idea what we are going to do. The impact partners can tell the way of these elements, and if you score this together, then it can give you a result, whether you are going for a plus or a min or a 0. And that's how we are want to make an experiment with them and try to construct this impact tool and whether it works. So that we are going to do this year already after the summer period, and we are being helped by another organization which are going to interview all these impact partners and making this kind of scoring tables, probably also for different weather elements. And then we are trying to to get a more grip on impact-based, impact-oriented forecasting. Well, this is very shortly an idea of what we are working on. Probably I was not clear all the time. It's just two aspects of our warning system. So it's more regional detail, which I told you about, and how we are tweaking our hybrid impact system more and more. And the most important lessons, I think, for a good warning is know where your users are, know what their needs are. You can make very interesting and scientifically correct things, but if nobody understands them, it's completely useless. So I think really that proper warning is more a communication problem than a physical problem, because I think the models, but also the skills of the forecasters are getting better and better. I think the information the physical information is getting better and better, but it's now more a challenge to get the best information to the user. So, and that's I think a communication problem. That's a statement I want to make. And the second one is if you want to do something with impact-oriented forecasting, what's very important is that you have good agreements with your civil protection authorities, and that you have point of contacts within these organizations where you can rely on, also in times of crisis in the warm phase. Well, that's my talk for today. It's 10 before 12, so it's maybe there's some time for some questions. And this was this is close to my house. We like skating in the Netherlands, and this is my daughter. So I wanted to end with this very nice picture of some meteorology in the lowlands. So I thank you very much for your attention. I hope it was not too boring. And if you have some questions, I can try to answer them. But maybe maybe it was all clear. So thank you very much.
Thank you for the presentation. And we have 3 questions at the moment. So I will post the first one from the Ivan in the chat. Maybe you should open the chat because there is a lot of questions, actually. In the top part of the screen, there should be a chat drop-down. You're muted, so.
Oh, sorry, I was muted.
Yeah.
Sorry. Yeah.
You find the questions in the chat.
Yeah. Okay. I shall go through them. Very nice. There's a lot. I didn't see.
Yes, there is a lot.
So now I was. Vida. Let me have a look. I go from the down to the top because it jumps all the time. Weather forecasts use probabilistic forecasts, but it's very difficult to assess impact. Does any criteria for weather impact for it's very that's right. It's very difficult to assess impact. That's also for I I can show here the questions, maybe more handy. And this is it's difficult to assess impact and weather criteria impact for. I don't understand completely this question, but it's very difficult to assess it. That's right. But when you are getting more and more used to your customer, and you have this good relationship, then you get more and more the idea of what's interesting and where are the vulnerabilities for this specific thing. I think the Met Office UK worked very nice also on this. They have this embedded advisors, which are really people from the Met Office, which are working by the civil protection authorities, and they get more and more an idea of what kind of weather impacts this certain field. And so we also do this in the Netherlands. We don't have KNMI people working at that organizations, but we have point of contacts which we are in close relation to, and on this way we are getting more and more an idea of impact. I see here how many was the damage of the storm situation. It was about 250 million euros. So that was really a lot. It's jumping a little bit. I see here Eric Söderström. I have a question. When you ask organization authorities to assess the impact, how fast are they required to respond? What I am getting might be time critical to get warning out. Yeah, this is very good. Of course, we are very operational people all, and you don't want to issue the warning when the weather is already done. That's completely right, and that's always a struggle. How we work with time is as follows. When we see an event coming, we have a weekly briefing with all these civil protection authorities. I didn't tell this, that's every Monday. And then we already make an appointment, or we fix a meeting if something's going to happen. And the threshold for this is a probability of 30% of an amber code. Then we already are planning a next meeting with the whole team. And then in the meanwhile, these organizations can already work on their impact profile, and that's how we work with time. And if you make good appointments for that, then it works quite well. We had this winter storm, Darcy, in last winter, and we did it already in this way, and it worked already very good. So that's how we do this. So we make in the early warning, we make already appointments with all these impact partners. I see here Oren Davidov. Also, I met you in Israel. Very nice to see you. Thank you, Jos, for your nice presentation. Do you also utilize, or perhaps are thinking of utilizing future media and of person to convey your warnings and their impacts? Yeah, that's right. We have we communicate our warnings via, of course, via the internet, but also via Instagram, Twitter, and also our app. And we have come to the conclusion recently that for the fast information, as warning is, we want to completely change to communicating via an app. So that's also part of this project, that we are making a new app which is completely dedicated to warning information. So and we are also thinking about, and I don't know how far we are with this, that there is also a way that users of this app can give feedback to the severe weather they experience. So that's already all being done in Belgium, I know. So that's also yeah, the case. Let me have a look. I see Laura Comina here. Yeah, about this score table. Yeah, we are going to build this score table with use of another professional organization in the Netherlands, and they are going to do a lot of interviews with all these impact partners, and they will try to build this scoring table. It comes a little bit out of the blue maybe, but in the way we are working now already, this hybrid impact system, we already use this scoring, but it's being done more subjectively, and now we are putting all this information together in a more objective scoring table. So it's not something completely new, but we want to build out this further. Now, how much effort would you implement such a system in the Adriatic coast? There are mountains surrounding the sea. The winds are the Bora. Yeah, I think we are, as the Netherlands, we are maybe in an advantage that we have in a quite overviewable area in the Netherlands. It's mostly a flat country, and so the weather is not to say not very homogeneous, but quite homogeneous. And I think really in more mountain area in the Alps, such a system is really more difficult. But on the other hand, if you work and if you know where the critical meteorological events are, and you have knowledge of that together in discussion with your crisis partners, then you can of course also work more or less in the same way. But maybe in this like this Bora situations or this very intense weather events, maybe also in winter time with freezing rain, for example, in these areas and more inland, then the impact already is so large that you might that you could rely probably for a big part already on meteorological criteria. So it's really also dependent on the kind of weather you're expecting in how much you have to put in your impact. Yeah, the potential impact knowledge database. So yeah, that's actually this potential impact knowledge base. The idea of this and what we already have worked out is that these are just known impacts dependent on known variables. So time of the year, time of the day, where this database is filtered. So that's how that works for now. I see Frans. Guten Morgen. In your app example, a warning on the current day was in stripes. On the following day, on the other hand, a yellow bar. What does the difference mean? Yeah, that's a good question. Yeah, I could not tell everything, but for example, for convection, we want to warn, like in a pre-warning system, that we have a pre-warning for example, in stripes, and when it's really happening, that we then make a massive color. How to say that in English? That you have the full color. That will be probably the case for convection to work like this. And I know that DVD also works in this way with convection. I see one from Pio. What do you think about crossing real-time geospatial information of high impact bases, airports, things like that, with weather information tools? as results to assess? Yeah, it's a very good question. I also didn't tell that because my time is limited. We are working on a GeoWeb platform. A lot of colleagues from and there we have the possibility to combine web layers of georeference data. The things you really you cannot imagine of it's available, like web layers. We can combine them with, for example, meteorological information to assess very quickly where the impact could be crucial. And so that's also a part of the development. But to be honest, to work this out, that's something for the next phase of our warning system. But we are preparing already this geospatial information that our system is ready to combine this with meteorological information, and that can help, of course, also in getting a better idea of your impact. I see Asa Graström. What is the work process when the forecast changes and the warning might need to be revised? Yeah, that's also a very good question. Of course, there's always a looping system in this, and I showed it also in the presentation, that you can, of course, always reconsider the choices you made. But there comes a point in time, for example, when you issue an amber warning or a red warning, that you cannot go back, or and then you have to, then it might be a false alarm, of course, because the meteorology turns another way than you had foreseen. Sometimes that happens still, but there is always a way to reconsider your warning. That's built in this process, and of course you hope that you work gradually towards a code from early warning to short warning. But sometimes you see the difficult, predictable situations that you need to revise them. So that's a problem which is still there, of course. Peter, if various partners have highly different sensibilities to various types of weather, which even depend on such factors as time of year, why is the goal of your approach to condense the warning into one bulk color code for all? Yeah, that's not really true. It's, of course, I also thought that's why I took these two variables of the warning system. We have, on one hand, we have the more regionalization, which we can, of course, differentiate in different colors, of course, and that is still be possible in the new system. But basically, you're right. For example, especially when you have a large-scale weather phenomenon such as wind, then probably you have for a large area you have the same warning, which might differ in impact dependent on your location. But if you have convection, for example, severe convection, there it will be well possible to warn specific users combined with impact with a red warning. Well, an other person 50 kilometers away has just a yellow warning. So that's there we can, of course, make more detail. And our algorithm will help probably with this assessment. Let me have a look. Katrien Desje, you mentioned that in the new system one of the aspects is differentiation between the public and professional user. How effectively will this differentiation show, and how do you make sure that the needs of all pro users are met? Can every pro user access the weighting and tweak it towards their individual needs, and even those who are not in your current expertise? That's a very nice question, and it's also quite difficult one, I think. This is a problem we have overthought, of course, also. And I think for now, the first answer is that if you talk about professional users, what they really want is most of the time more specific information for their specific activity, and there you can, of course, differentiate. On the other hand, if you, for example, say to a professional user, well, to you it's a yellow code, and you say to the general public it's an orange code, and then you have something to explain. So you have to be very careful with this. So for now, we have in the Netherlands, we have safety regions. There are some clustered municipalities, and they already get, it's quite new, they get a more dedicated product, but that's not, it has to be consistent, of course, with you are doing with the general public. And if not, then you have to explain very carefully to the professional users that it's a dedicated system for them. So that's some criteria which you have to take into account if you're thinking about these professional users. Let me have a look. I go up, and then Branko. How much effort would it take to implement a system? I had it already. Laura.
I think you have caught up with all the questions, and now we have 2 follow-up questions on the end of the list from Pieter and Hassan.
All right. Yeah. You are the moderator, Tommy. So they are coming now.
Yeah. In the chat, last 2 questions from Pieter.
Peter. Yeah. And do 2 different types of users at the same location also get different warning colors, because the impact on them can be very different because of who they are? That's a very good question. In the end phase of our system, it's our goal to really make a warning system which is personalized. So indeed, that it can depend on the person who gets the warning, how what the level is of the warning. But there's some time for us to investigate how to implement this as good as possible, because that's still some steps away from where we are now. But basically, yeah, it could be the case in the future. Hassan, have you done an evaluation of this new system? Yeah, well, we have evaluated the current system very thoroughly. We did public interviews with we did a special interviewing organization, or how to say that. They did a lot of interviews among random people and users, this especially about the general public, and a lot of the ideas which I presented, and I presented only a few, are based on these interviews and this evaluation. And of course, we are now this year we are making the first steps of the change of this warning system, and that will also be evaluated, of course. So that's Very nice, and it's very. I can very how to say suggest you all to do like a public evaluation that you just interview of. You can do this by a bureau or agency which does these interviews with a lot of people, that you get a good idea where the public is and where their needs are. And so we found out, for example, in this evaluation that the color codes are very strong. It's a very strong way, and people like this very much, to be warned by a color. So that was for us a confirmation. All right, you have to go on with our color system. And also, what came out is that that people, they say, all right, you are expecting this weather, but what's being expected from me now? What do I have to do? So all these things which are maybe quite obvious are then coming from such an evaluation. So I can recommend you that very much. Let me have a look. Ellen, thank you for the great overview. Could you explain a little bit more about the impact tool? Do you mean impact model which take all of it? Yeah. It's of course implicitly this impact model is of course not a numerical model as we know in weather forecasting, but it's the view of the crisis partner on that current situation, and there he can score the expected impact on that certain event. So that's and there in this scoring, this crisis expert from, for example, railroads, he can take the exposure and all these variables into account to score this. So that's how it basically should work, and which already works like this in our weather impact team, but now we want to make it more objective. So Manfred, very interesting. I wonder how complicated to organize a video conference with all the impact partners to discuss the impact of short-term critical weather situation, especially if it's Saturday evening. Is it really working 24/7? Yeah, Manfred, what here is very important, and I really hated this phrase years ago, but when you want to have a good crisis organization, what's very important is that you know the people, that when you are talking to each other at Saturday evening, that you know the person which you are talking to, because that makes things work. So this crisis management only works when you have a good network, when your relations are okay, when you can, now with COVID it's more difficult, but when you really know each other. So it's relation management, which you already stated. And besides that, of course, you need to organize it in a way that this impact team is also beneficial for their own organization. So there is a benefit for KNMI to make the best and most probable weather warning, but it's also for information of its impact partners how they should work with this information in their own working field. So you need to make something that you have mutual understanding and that you have also mutual benefit of the situation. And in that case, it can work 24/7, but of course, luckily with our numerical models and our models which are getting better and better, if you look at ECMWF, for example, things are being early warned. Of course, if possible, you try to do this impact meetings on a time when it's suitable for the most people. So this can be done most of the time, of course, during office hours, also in the weekends. But if necessary, also on a Saturday night. So, but yeah, good agreements are very important for this. Yeah, to organize the video conference, of course, now with COVID, everybody is working on remote. So that is I think one of the things we learned from COVID, that we can also from home, you can very easily come together to discuss about a situation and a possible red warning. I think
that those are all the questions.
Yeah, I have them all, is it? Yeah.
Considering the amount of the questions, maybe you can share the email so that people can send you follow-up questions.
Oh yeah, of course, that's no problem. I will.
Maybe in the chat, or if you have it on the.
Yeah, I type it in now. Yeah, I'm in this project team of issuing this constructing this new system, or just upgrading our current system. If you want to discuss things, just feel free to email me. We have already some contacts with France from DVD, and with Switzerland. We're also collaborating on how to build this in the future, especially this impact-oriented forecasting. So feel free to contact me if you want to share your thoughts or discuss something. We, as a team in KNMI, we are very open for collaboration, because we can help each other a lot with this. So yeah, just feel free to contact me, and then I can discuss it within in my own team, and then probably we can work further on it. So because yeah, we have all the same purpose, and that's to reduce the amount of impact to provide a safe society where people can do the things they want to do in the way they like. So I think that's the primary job of the weather service. I see Chauvin. Nice, thanks. Yeah, so Tommy, you will end this this thing. Thank you very much, all, and
thank you for the presentation and the amount of questions.
Yeah, probably I will meet. I saw a lot of familiar names and probably we will meet when COVID is over. We can meet on a conference or on a meeting and discuss it face to face. I find it still a lot nicer, because I'm now talking 1.5 hours to a screen, so it's a little bit funny. But I hope to meet you all one day, and that we can share our thoughts about this interesting subject.
Yeah, so once again, thank you for the great presentation. And I'm stopping the recording.